as you can see from this title, there might be a few concepts in here that you have never heard from before, or you might assume that I'm doing something in particular that actually is very different from what we're actually trying to do. So this is work that's been done both by myself and with my supervisor, Dr. Sedig, at the University of Western Ontario. So briefly, I'm going to go over some of the conceptual background, which is how we have tried to frame the design of games, looking at it from the perspective of how it influences the way that people think, rather than the way that people actually feel or enjoy what they are doing. And then I'm going to actually look at a study that we conducted to see whether this particular way of looking at games actually makes sense and has some kind of result that is measurable. So first of all, I'm going to be using the term gameplay, and I'm using it in a general sense to refer to the experiences that emerge as someone interacts with the game. Sometimes people use the term gameplay experience as maybe a transfer over from user experience, but we're using it simply to refer to the experience overall. So if we have a player and there's some interaction with a game, the gameplay is that which actually emerges from this interaction. So it is the experience that they have. And that includes the interaction itself, but we also want to look at what actually happens as they interact. And we can divide this up into different components. And so oftentimes people look at very particular aspects of gameplay and either call this gameplay or call it something very particular. But a lot of the different aspects that are looked at, whether this has to do with immersion or flow, often have to do more with affective or the feelings that people have of the experience. Whereas we're actually going to be looking at the cognitive aspects. So not necessarily does this make someone smarter, but more what are people thinking about when they're playing a game, and whether we can manipulate that to some degree. And the way that we're actually looking at cognition is using the lens of the theory of distributed cognition. So here we have sort of a traditional way of looking at cognition where you have a person, there's some input, they do some internal calculations, and there's output. But we're actually looking at it in terms of cognition as a system. So you can define what is actually going on as you have a human being and all sorts of other pieces of technology that they interact with. There's some relationships between these, and cognition is actually what occurs within the entire system rather than in an individual. And what this particular lens allows is it allows us to look at how we can use technology to affect the thinking of individuals. And so the result is how cognition actually works, how effective it is, depends not simply on the human who is involved, but the technology that they have available and they can interact with. And since we can't really design people, directly at least, then we need to design what they're interacting with. And so we can actually try to develop the tools that they use. In this case, looking at how we design games. But there's also how well these components are integrated. I could have a game that does a great job of making me think. Likewise, I could have some other device that greatly helps me with all sorts of calculations I need to do during the day. If I can't use that, then that device is largely useless overall. So we have to also look at how well these things can be integrated, how well you can interact with these objects. So then, this brings into the notion of cognitive gameplay. So we have a player-game cognitive system. In other words, we have a game itself and the player, and that is pretty much all that we are looking at for this system. Then cognition is what actually emerges from this system. So various mental processes that occur, the tasks that people are engaged in, and the various activities that they do. So whether this be perceptual processing at a lower level, whether it be problem solving at a much higher level, and then everything in between that. And that then emerges from the interaction that occurs. So by cognitive gameplay, we are actually referring to all these different processes that occur, but as a result of the interaction. So rather than designing particularly learning, we are looking at how can we design the interaction such that the learning which results is somehow different. So clearly, just briefly, how we talk about interaction, we've broken it down into different components. First, we look at sort of there's the action that a person performs on the user interface. This is one component. Then, as a result, the game performs some reaction. There's a change in the user interface to some degree. And the player perceives that change and then acts again. So this particular cycle of action, reaction, and perception is what ultimately is involved in the interaction. And although we can't necessarily design the perception, we can design both the action that is involved and the reaction that occurs. Now, what we're actually looking at, there's been some work done on those components, and I'm not presenting that here. I'm actually presenting something that has to do with interactivity. In other words, the quality of the interaction itself. And as a result of this, since cognitive gameplay results from the interaction, the quality of the interaction actually influences the quality of the cognitive gameplay. And we can look at this at the macroscopic level in terms of all the different interactions that people can perform, or we can look at it at the micro level, where you take one particular interaction that someone is doing, you break that down into its various components, and then see what those components are, and how these things can in turn affect the gameplay that results. So each interaction is composed of particular structural elements. We've identified 12, 6 for action, 6 for reaction. That's in another paper. But as some examples, so there's the focus in terms of where the focus of the action happens to be, the agency or the mode by which you articulate the action that you are performing, or timing in terms of how much time you have to perform an action and whether there's any restrictions on that and what kind of restrictions those might be. These are actually at a very abstract level. So we're not looking in terms of particular actions that people perform in terms of a mouse click or a tapping on the screen or hand waving. Those are all different ways that you can implement particular patterns of action and particular patterns of these different elements. One of these elements, oh yes, and then each of these elements can be operationalized in different ways. And those are the different ways that you can actually implement it, and then assumably those affect interactivity. One of these that we're looking at is activation time. And this has to do with when the reaction actually occurs. So typically, people think of playing games, they look at immediate activation time. This means that if I click on something, I see a reaction immediately. In contrast, we could also have on-demand activation time, which means that you perform an action, but the game does not automatically respond to show you what has happened. And then we wanted to see whether that slight change actually influences the way that people think about the game. So what we did was we developed 2 computer games just for this PC here. And each of these games had 2 versions. So one for immediate activation time, one for on-demand activation time. And the only differences between the versions of a particular game was in terms of this particular operationalization of that element. The 2 games were different games. All of them were just 2D puzzle games because these were simple to make, and they're easy for players to pick up and play. We also assume that there's already some degree of cognitive gameplay there, given that it's a puzzle of some sort. And since they're both puzzle games, then it means that it's just in one genre. So we don't have to worry about differences between genres in terms of whether there's any influence that way. But we wanted to use 2 games to make sure that if we just test one, that this effect isn't simply because of that game. It actually is because of something we're doing with activation time. So just quickly, because I have some time, and you'll get a sense, too, of how these work. Okay, good. So this is the game. You have different symbols here, and the goal is pretty much a match 3. So you want to match up all of the symbols so that they are in a set of 3. And so I can click on this one, I can move it here, and then I can click on this one and move it here, and so on. So by immediate activation time here, I mean that I've clicked on this, I click over here, and it moves. And when I've got all of them in rows, okay, the level completes, I get some score, and I move on. I've turned the sound off simply for ease of use here. There's 20 levels, and so on. The other version of the game has the exact same levels, everything else is the same. The only difference is you might notice that there's this here. So what happens is if I want to try to move something, the game tells me, okay, I've registered that movement, but I'm not showing you what is going to happen. And in order to actually see that, I have to complete my actions and then click go. And then it will show me what happens. And since this did not actually finish the puzzle, it resets. The other game that we looked at was also in terms of a puzzle. So here we have this particular laser gun. It shoots a laser upwards, and we want to get it to actually go through all of the different rings that are on the screen, and we use these to sort of redirect the laser. So if I put this here, the laser will fire. Oh, good, you can actually see that. And then I can move this around and try to figure out how I want to get the laser to hit all of the different rings. And if I can do that, the level is complete, and I can move on to the next level. This is with immediate activation time, so you notice how the laser will immediately fire to show you what is going on, what the path is like, and whether you've succeeded in this puzzle or not. The on-demand activation time, otherwise, I have to put things down, I can try to figure it out, and then if I'm ready, I click fire, and that's when it fires. Similar then to the other game, Tempo Swap, where you have to actually click go to see how things move around. So these are the two different games. If I can find my presentation. Here. So we recruited 40 university students. There was an equal split between male and female, which was really good. Most of them identified as not gamers and that they had very little experience playing games. We had a 1-hour game playing session where they filled out a survey, they played the game for 25 minutes, and then they filled out sort of a design questionnaire afterwards to tell us what they thought. We recorded their comments, we asked them questions during the game about what they were thinking, and we randomly assigned them to all these different versions. Each person only played one version of the game. Then some of the participants participated in an interview session where they got a chance to see the other version of the game they played and then compare the two and make comments. So it's just mainly the recordings of what they've said, their observations, and writing on these surveys. So I've broken the results down into sort of each of the different versions so we can see differences between what people reported playing. So with the Tempo Swap game, the immediate version, there were fragmentary planning and low mental effort, and this is based on the interview comments. So for example, one participant said, I just moved pieces around for the most part. If I knew a certain set was supposed to be somewhere, I stuck it there. Or this game is low difficulty, you could try and move tiles randomly until they matched, and many of the participants actually did that. And then I just kept trying different shapes and kept moving things until it worked. So this is sort of the mental process that people were using to solve this game. In contrast, the on-demand activation actually required a significant mental effort, particularly in terms of memory. So one person actually said, if I could do it one at a time and have them swap, I could see it, but I have to think instead. The most difficult part is to remember where the pieces are. That's why I keep failing and trying again, because I keep forgetting my moves. And then another one that actually compared the two in the interview said, you don't have to remember anything in immediate, the Tempo Swap immediate. You make a plan, and then based on that you make a new plan, but there's no planning. You're not planning 3 or 4 steps ahead. You're not having to think of the bigger picture. So this shows that there actually was a difference in the way that people approached the game, how they thought about solving it, based purely on this difference. So then we wanted to see whether the same thing occurred in the other game. And we found actually something similar, but not exactly the same. So in Tempo Swap, people just sort of did whatever, and they solved it, and they felt good about it. Here, people wanted to do planning, but they found that the game prevented them. So I guess by going step by step, this forces me to solve it in a certain sequence. Because I have to put down one at a time and it shows me the solution, this is a step-by-step process. Or I don't really plan much, it shoots every time, so I just go with whatever it's doing. And then someone else said, I found it frustrating. I wish I could have said, okay, execute, or had a button to say, go now, which is actually what was in the on-demand version. So these people, again, wanted to try to plan, but the game actually prevented them from doing that. The on-demand activation time version, they had to actually think about it in their head. So one participant said, I'm attempting to predict the entire path. I'm trying to simulate the entire thing in my mind. Another person said, I did trial and error in my mind a lot, which is why it was so demanding on my memory. So here, this is showing that the person is actually thinking about it internally in terms of what's going on. So in summary, if we actually want to design how people are thinking, then this clearly is some way that we can actually go about doing that. In particular, activation time seems to be something that has an influence here, that it changes the way that people are thinking, whether there's more going on internally versus just trying to go with whatever the game is showing them. There's some limitations. I showed mainly the qualitative data because we didn't have enough people to really get some good quantitative data out of this. The participants are from a wide variety of academic backgrounds, and that may have had some influence. And it would be nice to also try it in other genres outside of puzzle games to see whether we still get the same effect, or if this is something particular to puzzle games. And that is all for my presentation.